Okay, here we are on level 2, 7G1, exercise set 2. This is number 12. Create a truth table to determine whether the following argument is valid or invalid. So we've got 3 premises and a conclusion. And what I've done is I've already gone ahead and built the truth table, okay? And with the truth table, it's got 4 lines because we've got 2 elementary premises, C and D. And then I put on here each of the premises. Here's premise 1, premise 2, premise 3, and the conclusion. And I've gone ahead and highlighted the columns that are under the main operator in each of these lines, the premises and the conclusion, because that's what we really need. Once we know the truth values for the main operators of the premises and the conclusion, then we can determine whether or not this argument is valid or invalid. Because here's what we're ultimately looking for. An argument is valid whenever the premises are all true. An argument is valid if whenever the premises are all true, the conclusion is also true. If the premises aren't true, and the conclusion doesn't matter what the conclusion is, it's valid. The only time that this is going to be an invalid argument is if you get one of these lines where the premises truth values is all true, but the conclusion is false. That's what we're ultimately looking for. Okay, so now we can just kind of mechanically fill in the truth values here. We start with C and D, and we do this just like we do every other one. True, true, false, false. And why do we do that? And then we do true, false, false. Why are we doing that? Because that gives us every possible combination of truth values of C and D. Okay, now, you know what I'm going to do? I'm going to go ahead and copy. Actually, I'll copy the C column. And everywhere that I see C, I just copy that in. C, C, C. I'm going to do the same thing with the D column. Copy, and then everywhere I see a D, and drop that in. D, and D. Now that gives me a lot. Now, what about this not C column? Well, not C is just going to be the opposite of whatever the C column is, right? Whenever C is true, not C is false. Whenever C is false, not C is true. So if C is true, true, false, false, then not C is going to be false, false, whoops, true, true. And the same for not D. If D is true, false, then not D is going to be false, true, false, true. Okay. Now I can go back and let's see where that leaves me. Let's start with premise 1 here. The main operator column is an OR statement. Now an OR statement is going to be true if at least one of the disjuncts has a true value. Okay, so in this case they're both true, so this line is true. In this one, the C is true, so it's true. In this one, the D is true, so we got it true. In this one, they're both false, so it's false. All right. What about here? We got if D, then not C. Now a horseshoe is going to be true in virtually every combination except where the D is true and what comes after is false. So if it's like if P then Q, as long as it's true in every case except where P is true and Q is false. Well, what do we have in the first line? D is true and not C is false. So the horseshoe truth value is false. In this one, it's if false, then false. That's actually going to be true, okay? And this one is if true, then true. Definitely true. And this one is if false, then true. I know this might confuse you, but that makes it true. Okay. If you need to review how we get the truth values, how we work out the truth values of, say, a horseshoe or disjunction or conjunction, go back and review that in the book. All right. Now we've got the horseshoe value again. So we've got if true, then false. That makes it true. We got if true. Whoa, I'm sorry. If true then false makes it false. We got if true then true is true. If false then false, that's true. And if false then true is true. And finally, before we work out the main operator for the conclusion, first of all, we got to resolve what's inside the parentheses here, which is the conjunction is the main operator inside the parentheses. So the conjunction is going to be true if both conjuncts are true. So true, false, false, false. And then we've got not this. So the negation sign really ranges over. It's the opposite of the main operator column that's inside the parentheses. So this tells us here's what's true inside the parentheses ultimately, and this says not that, the opposite of that. All right. So based on that, keep that in mind. I'm looking at this column and I'm just going to flip the value. So it's going to be false, true, true, true. False, true, true, true. Okay, we filled out the whole truth table. Now we can determine whether this is valid or not. So keep your eyes on the highlighted columns, all right? Because the truth values of the main operators give us the truth values of those entire statements. So is there, first of all, let's look and see, are there any of these lines where the premises are all true? We get true, false, false, true, false, false. Okay, so that one, they're not all true. This one we got, hey, they are all true, three truths, and the conclusion's true. So far, so good. This one we've got, this column here, sorry, true, 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 and true conclusion. So far, so good, so valid. And this one we've got false premise. Now, that means that this line is a valid line. So this entire argument, the truth table tells us it's valid. Why do we do that? Because whenever the premises were all true up here, the conclusion was also true. Here's the two lines where the premises were all true and the conclusion was also true. Now, you might think, wait a minute, but what about these lines where the premises were false? It doesn't matter. That doesn't invalidate the argument. If the premises are false, it doesn't matter if the conclusion is true or false. That doesn't invalidate it. So this is the argument.